With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start this question. This question says that we need to find the number of real roots of the equation x power 5 plus e power 8x equals 0. And the options are, first option is 0, second option is 1, third option is 2, fourth option is 3. So let us consider this expression as fx, that is fx equals x power 5 plus e power 8x. Then f dash x is basically equal to 5 times x power 4 plus derivative of e power 8x, that will be 8 times e power 8x. First we differentiate e power 8x with respect to 8x, that gives us e power 8x. Then we differentiate 8x with respect to x, that gives the 8 in multiplication. So that is f dash x. Now x power 4 is always greater than or equal to 0. So similarly for 5 times x power 4 also, because 5 is greater than 0. Now 8 times e power 8x, that is basically always strictly greater than 0. So therefore what we can say is that 5 times x power 4 plus 8 times e power 8x, e power 8x is always greater than 0, 8 times e power 8x is always greater than 0 as 8 is positive. So this is always strictly greater than 0 for all x belonging to R. Now this implies that f dash x is strictly greater than 0 for all x belonging to R. So for all real x, f dash x is always strictly greater than 0. Therefore fx is strictly increasing. Fx is strictly increasing. So fx can have at most one real root. So fx can have at most one real root, because if fx had two real roots, that f of x1 be equal to f of x2 be equal to 0, that is x1 and x2 are roots of f, then this would imply by Rolle's theorem, what would have been possible, that f on x1, so suppose here that x1 is greater than x2, so f on x1 minus f on x2, that would have been equal to x1 minus x2 times f dash some c. Now this is 0 and this is x1 minus x2 is greater than 0 and f dash c is always greater than 0, just we have shown. So this part is always greater than 0 and this part is equal to 0, a contradiction. So we can say that f can have at most one real root. Now limit x going to plus infinity of fx, that is basically plus infinity, that is infinity, because the first term here that goes to infinity as x goes to infinity, and this also goes to infinity as x goes to infinity. So fx goes to infinity as x goes to plus infinity. Now as x goes to minus infinity, x power 5 being odd, this goes to minus infinity first term, and this goes to 0 because 8x goes to minus infinity, so e power minus infinity is 0. So therefore fx goes to 0 as fx goes to minus infinity plus 0, that is minus infinity. So now as fx is also given to be continuous, by intermediate value property, what we can say is that there exists a C1 belonging to R such that f on c1 is 0 because fx can take arbitrarily large positive values as well as arbitrarily small negative values. So there exists a c1 such that f has a root, and we have just shown that it can have at most one root. So fx has exactly one real root. So fx has exactly one real root. This completes the question. Second option is correct one. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.